Let's start with the satellite image. So yeah, let me open the satellite picture, and as we can see that uh, it is a little slow. I don't know why, but yeah. So the satellite image currently suggests intense thunderstorm activity over the southern Jharkhand, part of northern Odisha, and West Bengal, and this is also impacting the part of Arunachal Pradesh and Sikkim as well. And apart from that, we don't see any significant thunderstorm activity over remaining part of India. Some patchy clouds can be seen over the Kerala region, but I don't think they are affecting land that much. Most of them are over the ocean. So yeah, this is uh, yeah. But this cloud cluster, which is near coast of Kerala, well, it actually appears to be advecting moisture toward the Bangalore region in South India, Karnataka and Kerala. So in effect, we will experience some sort of thunderstorm activity by evening or perhaps by and during the night today and tomorrow. So we can expect some showers, pre-monsoon showers over Bangalore, which may give some respite from the heat. Yeah, so this is all about the current satellite image. So most of the things are, I mean, mostly clear as to what uh, what are the reasons which are prominently active right now. So to understand further, if we look at the wind pattern, so let us start to check the wind pattern. This will give us the clear idea as to how the wind patterns are actually triggering this type of weather activity. So if we closely look at the region in the middle troposphere, this is around 700 hectopascal, we see the jet from this region from the north is converging actually, and so if we let me make it yeah, let's see if we can make a line. So here the winds are coming to from this region and winds are coming from this region. So there is a convergence of wind along this region. So most of the convergence is actually happening over here, and this convergence over here is actually what causing the rainfall over this region. So let's further understand. If we go further up in the atmosphere, let's go up to 250 hectopascal, around 12 kilometer height. You will clearly note there is a trough which is extending from Jammu and Kashmir, coming down up to central India, even reaching up to southern peninsula, and then turning back toward the northeast India. And this trough, let me make it a little much more clearer for you. So let's draw a line. So here the trough is, this jet stream is meandering here and going back again. So this is the trough. Now what is interesting here is to look at is to see here. Okay, let me draw this again. So look at this region. So what is happening in this region is that beyond this, you see this line, we have more air uh, going out of this region. Okay, so just look at this line, and less air coming in, more going out, less coming in. What does it mean? It means there is a divergence, coming less coming in, more going out. So this additional thing which is going out has to come from below. you know are you getting what I'm saying? So this not coming from this side but from the bottom to top. So from the, this is the upper atmosphere, so this has to come from the bottom of the atmosphere to compensate. And that the additional air which is coming from the surface is what causing the cloud formation, and that is how the rainfall is happening. So this is called the upper level divergence. So this is the typical behavior of the subtropical systems, that we have a jet stream where we have we have a cyclotropic flow, and here we have a deceleration, and then we have acceleration of wind, and that is what causing the upper level divergence. To compensate that upper level divergence, we will require a low level convergence, and that is what is manifesting as cloud formation over that particular region. Yeah, so how this will manifest in future, so let's clean it up, and then let's see how it will going to. So by evening, if you look at, it will likely to, likely to leave this region, and this divergence region will move further toward the Bangladesh, and then it will pass through the northeast India, and by 23rd of March it will mostly leave the Indian subcontinent, and following which we will see the uh, clear sky and less formation of clouds as well. So let's look at how the cloud condition will look like on 24th of March. So as we expect, we have only limited activity over northeast India on 24th of March, and all very limited activity over the subcontinent. Nothing prominent except some isolated thunderstorm over the southern peninsula India, mostly limited to Kerala and Karnataka. And following which we will see a commencement of western disturbance over the northern regions of Jammu and Kashmir by 26, and it will be mild in nature. Some sort of isolated rainfall and snowfall might be seen over the hilly stations, but as far as the intensity is concerned, it will be mild in nature, but it will last up to 27th of March. By 28th of March, it will weaken significantly, and by 29 you will see that most of the rainfall over northern region will vanish. So yeah, but isolated thunderstorm activity will continue over the southern peninsula India, mostly Kerala, and by 31st, and again the weather over the southern peninsula India will calm down a little bit, and again from 2nd of April, I guess the rainfall activity will I think not from third, I think from fourth of April the rainfall activity will again revive over the southern peninsula India, but it will be of some sort of mild in nature, not that strong. But let's see how, if this forecast holds true as we move further. Otherwise, if it turns out to be true, then it will give some decent rainfall over the southern peninsula India. So this is all about for now, and in the future video we will look at the weather condition which will prevail in the region uh, for after passing this system. So thank you very much for watching. I'll see you in the next video. Till then, bye bye and take care.